So the radicals that we've worked with so far have all had even radicans, right? Meaning that that number under the square root or a radican has always been a positive number here, right? So now we're going to look at what happens when we have radicals that have negative numbers, right? So this is where our imaginary number comes into play. So we call imaginary numbers I, right? And we're going to use the idea that the square root of -1 is equal to I, right? And so this helps us solve equations with a negative number in the radican. So one other thing to note is that I only works for even radicals, right? And that means that my index number, or that number on top of the square root, is an even number. So looking at this first example, right, I've got an even number, or my index is 2 because I'm taking the square root. Right? Whenever we have a negative radican, we want to rewrite our radical using that square root of -1, because I know that that's going to be equal to the variable I, times our +6 here, right? In past units, we were able to multiply like radicals together, right, as long as they had the same index number, and I could multiply the radicans and rewrite it. So we're just using that rule, but in the opposite direction here, right? And since I know I is equal to the square root of -1, I can use my substitution property and rewrite this as I times the square root of 6. Right. Next, I want to try to break down my square root of 6 using my factor tree. Right. I can try to break it down as 2 times 3. Right. 2 and 3 are prime numbers, and I can't group those together, so I know that the square root of 6 is already simplified as much as it can be. Right. So our final answer to simplify the square root of -6 is I root 6. In our second example, right, we've got the square root of -45. So again, we're going to rewrite this as the square root of -1 times the square root of 45. Right. I know the square root of -1 is equal to I. So I know it's going to be I times root 45. And then I want to go ahead and try to simplify root 45. Right? So I know it can be broken down to 9 and 5, and then 9 can be broken down into 3 and 3. These are all prime numbers on the outside here, so I can make my group of 3s and write it on the outside of my square root symbol with that 5 that's left over here. I don't want to forget about the I that's in front. Right? So I have I times 3 root 5. Right? And any numbers that are on the outside or variables, we can simplify or rewrite together just so it looks a little bit nicer as 3I root 5. In my third example, I've got -4 times the square root of -9. Right? Just like we did before with the coefficients, we're concerned about those at our last step when we multiply our groups together. So I'm still going to expand my square root of -9 to the square root of -1 times root 9. I'm going to use my substitution property again to have 4 times I times root 9. Right? I know my perfect squares, and I know that the square root of 9 simplifies to 3. Right? We still have multiplication going on between all 3 of these parts here. And I want to simplify this by multiplying my coefficients together. So negative 4 times 3 is negative 12 times I, which is negative 12I. Then my very last example has a perfect square here. So again, we're going to rewrite it as the square root of negative 1 times the square root of 36. All right, I'm still substituting in I times the square root of 36. And again, I know 36 simplifies to 6. And again, we always want to rewrite this in a more simplified or prettier manner. So I don't want to keep it as I times 6. I want to rewrite it as 6I.